Hello, welcome. Let's try to solve an interesting Leetcode problem, 946, validate stack sequences. And this is a very popular problem. So we are giving two integer arrays post and popped. So this post is 1, 2, 3, 4, 5, and popped is 4, 5, 3, 2, 1, and all with distinct values. We're going to return true if this could have been the result of a sequence post and pop operations or an initially empty stack, or we're gonna return a false. So the idea is that we're gonna do the push and pop operation just on an initially empty stack. Yeah, so let's just simulate the problem. So for example, for an empty stack, we're gonna do a push of 1 inside of the stack, and then we're gonna push 2, and then we're gonna push 3. So we have the push sequence 1, 2, 3, and then we're gonna push 4. Yeah. Now, as the pop operation, there's a 4, so we want to do a pop. So we push 4 and pop 4. Yeah. So inside of the push operation, so it is a 1, 2, 3, and 4. Yeah, but inside of the pop operation, it's gonna be 4, and then we're gonna push a 5. So this is the push, and we're gonna pop 5. So here gonna be the pop. We pop 5, and then we pop 3, 2, and 1. So this is the push operation, and this is the pop operation. So this is our sequence: push 1, 2, 3, 4, and we pop 4, and we pop 5, 3, 2, 1. Yeah, so this is just the description of the problem. But how can we solve this kind of problem easily? As it is just a push and pop operation, we might think about maybe we're gonna use some stack to solve the problem. But basically, we're gonna use the greedy idea. So currently, we have this number 4. But how can we find this number 4? Because in the pop operation, definitely there's a 4. So this means this 4 must be inside of the stack. Otherwise, how can we do the pop operation? So we're gonna prepare a pointer. So this is gonna be the position, and this position is gonna be pointed to this number 4. And we want to find this number 4 inside of the stack. So this means this 4 must be pushed inside of the stack. But if we want to push 4 inside of the stack, there are some other numbers. So it means we have to push other numbers like 1, 2, 3 first before we push 4 inside of the stack. Now we can simulate the problem by using a stack. So this is our stack. First of all, we're going to check the numbers inside of the push. We're going to push 1 inside of the stack, and 1 is not equal to this 4, and we're going to continue. 2, 3, not equal to this 4, we're going to continue. Currently, we have this number 4. First of all, we're going to push it inside. Because if we do not push it inside, how can we compare? If we were to pop an element, it means this element must be inside of the stack. So we're going to push this number 4 inside our stack. So this is our stack. And after that, we're going to compare this value on top of the stack, this 4 with this number 4. So what happens if they are equal? So if they are equal, we just pop out this number 4. We're going to pop out this number 4. Currently, we have this number 3. So we're going to compare with this 3 and 4. And this is 3 and 5, because this 4 has already been compared and they are equal. So if they are equal, so the position is going to be pointed to 5. So we're going to compare 3 and 5. They are not equal. So what are we going to do? We're going to continue to pop the other element. Maybe there's a 5. So we're going to continue to push 5 inside of the stack. Now, our pointer on top of the stack pointed to 5. 5 going to compare with this 5. They are equal. So we're going to pop it out. Now we're going to compare with this 3. They are equal. We're going to pop it out, and the position is going to be 2. And 2, they are equal. We're going to pop out, and this 1, they are equal. We're going to pop out. Now the stack is empty. So if it is empty, so we're going to return true. Otherwise, we're going to return a false. Yeah. So this is a greedy idea to solve the problem. So we're going to simulate it by using a stack. But how can we prove it? I mean, yeah, even though you can think about it, maybe we can solve it like that, but it's really difficult to prove it. If we do not do such operations, definitely it's not the optimum way to solve the problem. Yeah. So, for example, we have this number 4. Our current number is 4. This means all the numbers before it, definitely it should be inside a container. So currently we're going to use a stack. So this means like 1, 2, 3. Definitely we want to put it inside a stack. If we do not put it inside, just how can we compare? Maybe at some positions we have this value 3 going to compare with other values inside the popped array. So first of all, we want to put all those values inside a stack. Just prepare for the further operations for the pop. Yeah, currently for this number 4, we want to put it inside the stack, and we're going to compare this number 4. If they are equal, we're going to compare others. Yeah, because the sequence must be the opposite. So if there's a sequence of popped like this way, and the sequence of the pushed should be the opposite. So this is why we want to store it inside a stack. And if this is equal, we're going to compare with this element. Maybe this is 3, there's another 3 at this 5 position, but it is not. But if it is not, definitely we cannot do the operations for this 3. We want to check other numbers. So for example, maybe there's other numbers, maybe there's a 5. Yeah, so we want to put it inside. Yeah, maybe you think, maybe let me clear it up a little bit. Maybe you think, so currently I have 1, 2, 3 and 4 inside of the stack. I'm going to compare with this number 4 if they are equal, so I'm going to pop it out. Maybe this number is not 3, it is a 5. So what about this number is just 5? Yeah, so this is a 5. As they are unique, this is going to be 3. Yeah, so if they are if it is 5, it is still okay. We just compare, remove this 5. It means there's definitely there's a sequence. So because this 5 has already been pushed, and we're gonna pop it out. So now we have this number 2. Yeah, and we're gonna continue to the next number. It's gonna be 3. Yeah. So currently for this 2 and 3, they are not equal. So what are we gonna do? Do we need to put more element inside of the stack, or do we need to go backward to check with this number 1? You know, here is 3. Yeah, currently we have this number number 3, but if they are not equal, let's just check some constraints. Maybe all the elements is unique, and popped is just a permutation of pushed. Yeah. So I think it's going to be really difficult to prove this kind of a problem. Maybe some intuitions we just need to simulate the problem. So for example, if this number 2 is not equal to this number 3, if they are not equal, do we need to just check a further element? Maybe we want to put the 5, want to put this 3 inside of the stack to continue to check if they are equal, or we just go backward to find another number 1 if they are equal. Yeah, definitely we need to prove this one should not the optimal way to solve this problem. Yeah, because this one I don't think that is okay. So this is a 3, and this is a 2, and currently I have this 1. Yeah, but I don't need to do that. Maybe I want to do it later on, but I want to continue to put another number, maybe 3 inside, and 3 gonna compare with this 3. Yeah, so for such problem, if we cannot prove it, definitely it's really difficult to solve. Now let's just simulate the problem. Maybe I'm gonna prepare a stack and position so stack gonna be empty, and pricing gonna be 0 for the popped array. Now I want to check the numbers inside the stack. So for all the numbers inside the stack, I want to check while the stack is not empty, and stack minus 1 equal to the current number inside the popped array is going to be this position. So if they are equal, what I'm going to do is I want to pop out the element. So I want to pop out the element, and also for the position going to plus equal to 1. Yeah. But before that, we need to put all the numbers inside the stack. Now we have something inside the stack, and we're going to compare if they are not equal. And for the stack, it will pop out this element, and we're going to continue like this way. And finally, we have to check if the stack is empty or not. If it is empty, we're going to return true. Otherwise, we're going to return a false. This is not okay. Let me check. Yes, so for the first one it is okay, but for the second one, yeah, it should be false. Let me check. So this is the stack. So for numbers inside the stack, I want to append it inside while it is not empty, and this is equal. Yeah, the stack minus 1 should be equal to the position. So the stack should pop, and the position should plus equal to 1. Yeah, let me just check why it is wrong. So currently we have 1 for the second example. Yeah, so for numbers, yeah, it is not stack. Definitely I did something very stupid. It is not stack. So for this number inside the post array, our stack is empty. We want to append the element inside. Let's just simulate the second one. So first of all, we put 1 inside, and 2 inside, and 3 inside, and 4 inside. Now this 4 is going to compare with this 4. If they are equal, we're going to pop it out, and we're going to check this 3. It is equal. We're going to pop it out, and we're going to compare with this 2 and 5. So 2 and 5 not equal. What are we going to do? We're going to just continue to put 5 inside, and this 5 equal. Yeah. So we pop it out, and we go to 1. So this is 1, but here it is 2. They are not equal. So if they are not equal, can we go forward? Because this is a stack operation, we cannot do it like that. We have to check this 2 with this 1. If they are not equal, so we're going to return false. Yeah, because while we are designing this problem, it can never go forward. Yeah, because on top of the stack, we have to compare with the current element. It can never go forward because this is a stack operation. Yeah, so before checking this 1, we have to check this 2 first, because it puts inside. First we put 1, and then we put the 2. Now we want to compare with this 2 with a popped number. If we were to compare this 2 with popped number, definitely we can put some number inside to compare, but we can never pop it out to compare this 1 first. So this is why from beginning I didn't prove it. Now I think we find a solution to prove it, because this is a stack. We can never, this 2 has never been compared before we pop it out. Yeah, now this means we cannot compare 1 because this 2 is not popped out. So we have to put another 1 inside. Yeah, maybe we want to put 5 inside, and this 5 compared, and now we have this 2 and this 1. They are not equal, so we're gonna return false. So this is going to be the solution for the problem. Now let me make a submit to check if it works. As you can see, it works. So this is the ON solution. Thank you for watching. See you next time.